And very good morning to Madam Farhana. This, Today we will present about our report, which is autonomous emergency braking system during heavy traffic and parking. First, I will introduce my group member and myself, which is Muhammad Hakimi bin Mat Saufi, Muhammad Iman Daniel bin Muhammad Zaidi, Muhammad Saiful Anwar bin Muhammad Noor, Muhammad Zikri bin Zamri. First, we will start with the introduction about the system. General overview about the system. Heavy traffic congestion and parking issue have grown ubiquitous in today's bustling metropolitan surroundings. The autonomous emergency braking system is a technology that has emerged as a viable option to improve road safety and avoid accidents during heavy traffic and parking scenarios. It combines cutting-edge sensor technologies, real-time data analysis, and autonomous decision-making capabilities. By relying on a network of sensors such as radar, lidar, and cameras, the Aebs system continuously monitors the surrounding environments. The next topic is objective. Objectives of this report is to assess the performance, functionality, and limitation of the AAB system, while also considering its impact on reducing accident and improving overall traffic flow in congested environments. To develop the basic autonomous programming for autonomous emergency braking system prototype, to evaluate and analyze the effectiveness of an autonomous emergency braking system in mitigating potential collisions and enhancing safety during heavy traffic and parking scenarios. Next is the justification on why the system need to be integrated with IoT. First is real-time data exchange. IoT connectivity allows the AAB system to communicate and exchange data with other vehicles, infrastructure, and smart devices in real time. Second is advanced sensor function. IoT integration enables the AAB system to combine data from various sensors, both on board the vehicle and from external sources, such as traffic cameras or weather monitoring stations. Enhanced early warning system. By leveraging IoT connectivity, the AAB system can receive early warnings and alerts from infrastructure and other vehicles. Vehicle-to-vehicle communication. IoT integration allows vehicles equipped with AAB systems to communicate with each other. And the last is cloud-based analysis and learning. IoT connectivity enables the AAB system to transmit data to cloud platforms for analysis and learning. So we will continue with the Muhammad Zikri bin Zamri to present this chapter.
All right. This is my parts. The components involved. All right. For the first parts is microcontroller, Arduino Uno. So it is compatible with a variety of sensors and actuator device and can be programmed using Arduino programming language and the Arduino development environment. Number two is ultrasonic sensor. Right, it is used ultrasonic sound waves to measure target objects distance and then turns the sound that is reflected back into an electrical signal. Alright, number three is breadboard. The breadboard makes it simple and quick to connect electronic components. It typically consists of a grid of holes into which electronic components can be put and is constructed of plastic. Number 4 is motor driver L298N. The module is capable of driving DC motors with peak currents of up to 2 ampere and voltage range of 5 to 35 volts. It is a twin full bridge driver with high voltage and current that can drive inductive load, including relays, solenoids, DC motors, and stepping motors. And lastly, for the components is buzzer. A buzzer is an electrical device that makes a buzzing sound when activated. They are commonly used as a signaling device. Some buzzers are also used as speakers for electronic devices such as smartphones or computers. Right, we move to the software involved. Number 1 is Proteus. Right, the software program Proteus is used to simulate electronic circuits and microcontroller systems. Before developing electrical circuit designs, it is used to design, test, and verify them. The software offers a graphical user interface for creating and modeling circuits in addition to a large selection of simulation models for various electrical components such as microcontrollers, sensors, and actuators. Next, number 2 is Arduino IDE. The Arduino Integrated Development Environment (IDE) is a software application that allows users to write, upload, and run code on the Arduino board. The Arduino IDE is a simple, easy-to-use program that allows us to write, upload, and debug code on an Arduino board. It includes a code editor, a library manager, a serial monitor, and a built-in programmer. The code editor is used to write code in the Arduino programming language, which is based on C and C++. The library manager allows us to easily add and manage libraries of pre-written code that can be used to interact with different sensors, actuators, and other devices. The serial monitor allows us to see the output of our code and send data to the Arduino. Last for the software involved is MIT App Inventor. MIT App Inventor is an intuitive visual programming environment that allows everyone to build fully functional apps for Android phones, iPhones, and Android iOS tablets. Those new to MIT App Inventor can have a simple first app up and running in less than 30 minutes. And what is more, the blocks-based tool facilitates the creation of complex, high-impact apps in significantly less time than traditional programming environments. The MIT App Inventor project seeks to democratize software development by empowering all people, especially young people, to move from technology consumption to technology creation. All right, this is the system flowchart. I will begin with the stats, then positioning system and prototype sensor. Next is data fusions, distance between prototype and obstacle measurement. Next, the target obstacle trajectory prediction, collision detection, collision prediction, collision warning. Next to the collision avoidance control, which is Aebs system. And lastly to the end. So this is the process and activities offered by the proposed system. Collisions must occur and causing severe harm, serious injury, and even death. Accidents also usually happen while driving in the city because the car panics excessively to the point of experiencing emergency braking, so that sometimes we don't even realize it happening. To make life safer, we want to address the issue of repeated accidents by having an Aebs. Therefore, this project is important to ensure that the Aebs can function properly and achieve the desired purpose. Alright, for the first activities offers, which is assist the owner. The autonomous emergency braking system (AEBS) works when an infrared sensor detects an obstacle in front of the vehicle. The infrared sensor will provide the information to the microcontroller. When this occurs, the data will be interpreted by the microcontroller, which will then determine the distance between the car and the barrier. The microcontroller will command the motor driver L298 and to operate. Next is automatically function. For the purpose of pulling the brake pedal is attached to the brake system. When this happens, the brake caliper grips the brake disc and brings the vehicle to a complete stop. When the vehicle comes to a complete stop, this will come to an end. If the vehicle identifies an obstacle in front of it, this circumstance will reoccur. That's for my parts. Next, I pass to the next chapter. Thank you.
So I will continue with the user interface design of autonomous emergency braking system. Designing the user interface for an autonomous emergency braking system require prioritizing simplicity, clarity, and ease of use. The design enables user to adjust the emergency braking distance when in parking or heavy traffic situation. Uh, for the first function is a visual display. Visual display representation of the vehicle in parking or heavy traffic scenario. Utilize a simplified overhead view or 3D rendering. Color coding or shading indicates distance from the vehicle to obstacles or vehicles. Lastly is adjustable slider or numerical value display emergency braking distance. For the second one is adjustable distance control. Dedicated control element, slider or up or down arrow for adjusting emergency braking distance. Control element is easily visible and accessible on the interface. Real-time preview demonstrate change in braking distance as the control is adjusted. For the third one is default and preset setting. A safe and appropriate default emergency braking distance is set for typical parking and heavy traffic scenario. Preset options are offered for different driving conditions or user preference, such as city parking, highway traffic, or custom setting. User can save their preferred distance as a custom preset for future use. For the fourth is feedback and notification. Clear visual and auditory feedback is provided when the emergency braking distance is adjusted. Notification or warning are displayed if the selected distance is potentially unsafe or exceed recommended limit. For number 5 is help and information. A help section or tooltip page is included to provide users with information on how to emergency braking system work and the impact of adjusting the distance. Brief description or icons are offered to clarify the purpose of different control and settings. And lastly is confirmation and activation. Users are required to confirm any change to the emergency braking distance before they become active to avoid accident adjustment. A clear indication is provided to show when the emergency braking system is active or engaged. We continue with the purpose design of autonomous emergency braking system. For the figure on the left is the purpose design, and on the right side is a schematic diagram of the system. This is how the system works. Firstly, the AEV system includes an intuitive interface allowing users to adjust the emergency braking distance for parking or heavy traffic situation. User can set a preferred distance that activate the emergency braking mechanism. Electronic sensors. the AEB system utilize ultrasonic sensor to accurately detect obstacle and measure the distance. The sensors emit high-frequency sound wave that bounce off object, enabling the system to calculate the distance between the vehicle and the obstacle. Thirdly is signal processing. When the ultrasonic sensor detects the distance matching the user setting, whether it is in the parking or heavy traffic, it sends a signal to the Arduino or ECU, which acts as the central processing unit. The Arduino or ECU interprets the signal and executes the necessary action. Warning device. As a safety measure, the AEB system may activate the warning device such as a buzzer or visual indicator to alert the driver of imminent autonomic automatic braking. Lastly, brake activation. Upon receiving the signal, the Arduino or ECU reads the code instructions designed for the AEB system. The instruction dictate the action required for emergency braking. A DC motor engages the applied pressure to the brake pedal, reducing the vehicle speed or bringing it to a complete stop to mitigate collision risk. We move to the data analysis. Is the general road accident statistic in Malaysia. The descriptive analysis of the table is the analysis of general road accident statistic in Malaysia reveals a consistent decline in the number of accidents over the year. This positive trend reflects the effectiveness of road safety measures, awareness campaign, and improvement in infrastructure and regulation. Predictive analysis. Based on the heuristical data showing a decreasing trend in accidents, it is reasonable to predict that the number of accidents will continue to decrease in upcoming year. However, accurate prediction require considering factors such as a new road safety initiative, traffic pattern, and driver behavior. And lastly is prescriptive analysis. To further reduce accident in Malaysia, implementing advanced technologies like the IoT-based autonomous emergency braking system is crucial. The system utilizes electronic sensor, cameras, buzzers, and Arduino or ECU to detect potential collision and automatically apply the brake to prevent accident. By mitigating human error, which is a major cause of crash, the AEB system significantly contributes to accident prevention and reduction. That's all from my part. Saiful will continue for the next part.
We start with the advantages of the system to Unikl MFI. The first one is it can help to prevent or reduce the severity of collision on the campus. AEB can help to prevent or reduce the severity of collision involving university vehicles, such as cars, motorcycles, bus, and shuttle. This can help to protect students, faculty, and staff from injury or death. The second one is it can reduce the number of accidents involving pedestrians and cyclists on the campus. AEB can help to reduce the number of accidents involving pedestrians and cyclists on the campus. This is especially important in areas where there is a lot of foot traffic, such as near a library, classroom, and during halls. The third one is it can help to reduce the number of accidents involving distracted driver on the campus. AEB can help to reduce the number of accidents involving distracted driver on the campus. This is because AEB can automatically apply the brakes if the driver does not react in time to a potential collision. The last one is it can help to improve the safety of university transportation service. AEB can help to improve the safety of the university transportation service, such as a bus to go to the desired place. This is because AEB can help to prevent or reduce the severity of collision involving this vehicle. Okay, next. We move to the business opportunity to the market system. The business opportunity to the market autonomous emergency braking system is significant. There are several factors driving the growth of the AEB market. These include, number one, rising number of road accidents. The number of road accidents is increasing every year, and AEB can help to reduce the number of fatalities and injuries. The second one is stringent government regulation. Governments around the world are increasingly mandating AEB system on new cars. For example, the European Union has mandated that all new cars sold in Europe must be equipped with AEB by 2022. The last one is increasing demand for safety features. Drivers are increasingly demanding safety features in their cars, and AEB is one of the most popular features. Right, next. Target user and customer. There are several ways to market AEB system. One way is to target OEM, which is original equipment manufacturer. OEMs are the companies that make cars, and they are ones who ultimately decide which safety features to include in their cars. Another way to market AEB system is to target fleet managers. Fleet managers are responsible for the safety of their drivers and vehicles, and they are often willing to pay for the safety features that can help to prevent accidents. All right, last but not least, we have a conclusion. The mini project of the autonomous braking system showcase the potential of IoT technology in enhancing road safety and driving experience. It is a very user-friendly interface that developed for adjusting emergency braking distance. Drivers have control over the braking system in critical situations. For the customization of the emergency braking distance enhance safety. The practical application of IoT principles in the automotive industry. The integration sensor in connectivity and user interface device in vehicle safety system. The autonomous emergency braking system exemplify the IoT impacts on accident mitigation. The continued exploration of IT technology in automotive safety and other industry. The importance of user-centric design and tailored IoT solution. The last one is IoT revolutionize industry and improve quality of life. That is all from us. We hope you guys can understand that we are presenting the emergency that we are presenting autonomous emergency braking system and parking during the heavy traffic and the parking. And that's all from us. Thank you.
Z stop.